about substitution and elimination reactions. And the first thing I think I want to emphasize here is that we're going to be talking about reactions. And but we are going to be talking about this semester about 5 classes of reactions. And I will tell you, I'm feeling right now a huge sense of anticipation as we're beginning with these first 2 classes of reactions, substitution and elimination. So I'm having a, I may fall into sort of a little bit of a loud tone as I'm talking about this because I see what's coming. We are going to talk about 2 of the neatest things that we will address all semester in substitution and elimination reactions. So hold on to your hats. Here it goes. Now let's start out by saying that alkyl halides undergo substitution and elimination reactions. Okay, so substitution and elimination reactions. What are alkyl halides? Well, we know what an alkane is, right? An alkane might be, let's say, as an example, methane, right? Now I'll put one of these hydrogens out here so I can emphasize that an alkyl then, how do you spell alkyl, is going to be just that group. There's my alkyl group. There's methyl, right? So if this is methane, this is methyl, and I'm sorry about that messy writing. So alkyl halides are sp3 hybridized carbons that are bonded to a halogen, right? Where this is chlorine, bromine, or iodine, right? Those are alkyl halides. Turns out fluorine does have some similar reactions to these 3, but in particular, we're going to talk about these 3, chlorine, bromine, or iodine. This is not an alkyl halide. This is a real halide. This is a vinyl halide. So we're really talking about alkyl halides here. Now, to help you appreciate that, you're used to identifying hybridization of a particular atom. So be in the habit of doing that. If the hybridization of that carbon is sp3, then it's possible that we'll be talking about, it's possible you'll be dealing with alkyl halides. And the things that we're going to learn about substitution and elimination pertain to the system if you're looking at an sp3 hybridized carbon with a halogen there. So let's look at what a substitution is. It's just kind of what you might think it might be, right? So with nucleophiles, which we appreciated last chapter, we're going to get, that's going to come in, and that and that's going to go away. So it's a substitution, right? So you get a nucleophile that's being substituted, or rather a halogen that's being substituted with a nucleophile. So there's my substitution right there. You see that? Now an elimination is when I get a base that comes in. Let's take this hydrogen here. Boom, boom, and boom. Okay? So can you see that I'm eliminating my hydrogen and my halide, right? So we have a substitution and an elimination. The words themselves make a tremendous amount of sense if you think about what's going on. However, we're going to deal with these so much that they're going to end up just simply being old friends that you call, Bob and Fred, right? Okay, so alkyl halides can undergo an elimination reaction, or they can undergo a substitution reaction, and they can undergo an elimination reaction. Right, this is what alkyl halides do, and among other things, of course, but that's what we're talking about here in this conversation. Now, when the reagent can act as a nucleophile or a base, then we're going to have a competition between the 2 sometimes. Not always, but sometimes. So in this case, my nucleophile is hydroxide, right? And we could either have a base reaction, right? Right, not there. Oops, oops, oops. It's the electrons. It comes from the electrons, and those go here, right? We could either have that, or let's go with a different color. We could have right, and that's so blue or orange, right? The orange gives us this. Gives the elimination product, and the blue gives us the substitution product. Okay? So now I do want to use the term substrate. In the example above, which compound is the substrate? And the substrate is this thing here. That's the thing that's getting attacked. Okay? I will use that term, and I want you to be comfortable with that. Now, two main reasons why alkyl halides undergo substitution and elimination reactions is because, first of all, the halogen is electron withdrawing, so we've got this polar bond here. I promised you we'd get a lot out of that, and here's my delivering on this promise for the first time of many. So the halogen is electron withdrawing, and so that makes a partial positive here with this carbon, right? Makes a good target for a nucleophile. And so the first thing is electron withdrawing, and the second reason is that the halogen acts as a leaving group. It's the halogen acts as a leaving group, and for a substrate, or for this compound right here to have a substitution elimination. Man, please pardon me. I'm going to start that sentence over again. For a substrate to go through a reaction like this, it has to have a good leaving group. If it doesn't have a good leaving group, you're not going to get substitution or elimination, right? So what is a good leaving group? Well, makes tremendous amount of sense. Good leaving groups are things that are stable on their own. And in chapter 3, we talked about acids and conjugate bases. Remember that? And a good acid has a stable conjugate base. Stable. Right? And so really this pKa table now gives us a list of good leaving groups. This is genius. Because we know what good acids are, right? There's some decent acids, and the good ones are up here, right? Because we know what good acids are, we know these are stable, right? And these are not stable because they are not conjugate bases of good acids. All right. So that's a good start on it. I encourage you, if this doesn't make sense, if you've taken notes, consider going back and watching it again. This is the foundation for, wow, I mean the foundation for 10 chapters, I think, is this video right here. All right, good luck.